Simon, you're Professor of Isotope Geochemistry. Can you tell me a little bit about the research that you do and how you got into that field?
Most of my work is finding the ages of rocks. I mean, just put it simply. We use the decay of potassium, which produces argon, and we measure argon in rocks. We can do that in really, really small pieces of rock. So we measure the age of, say, a grain of sand. That takes us into all sorts of areas. So I've been involved in dating moon rocks and dating meteorites, grains of sand, literally grains of sand, volcanoes, mountains. I mean, it just means that I get involved in all different kinds of geology. I'm called a Professor of Isotope Geochemistry, but actually most of what I do is about geology. It's about earth sciences.
Why is it important to date the ages of all of those different rocks?
Well, if you're a volcanologist, you want to know the age of the volcano. You want to know when it erupted, how many times, how often it erupted, and that helps you understand the hazards that it is. If you are an oil reservoir engineer, you want to know when the oil got into the rocks, how it got into the rocks. So you need to know the age of the rock, when the rock was porous, in other words, when fluids could flow through, when the fluids actually flowed. That's the sort of information that we can provide.
Well, you've got some rocks here. Can you tell me a little bit about that one?
Yeah, sure. It's a basalt. It's from the Faroes, north of Scotland. It's actually about 56 million years old, and it's a lava flow. So the dark areas here are the original basalt, and as it came to the surface, it formed bubbles. So the bubbles are now full. They're not empty anymore. What happened was, after the rock had formed and it got buried, fluids were flowing through, and those fluids have deposited minerals in these holes. So they're now white. Most of this is calcite and zeolite and things like that. So it tells you not only was it a lava flow, but it was buried very quickly, and it had a lot of fluid flowing through it that deposited these minerals.
Well, those are really nice big textures that you can see in hand specimen, but you've also got these thin sections here.
If we could tell everything from a rock like that, it would be very simple. But a lot of textures and a lot of the minerals in this rock, it's quite fine grained, are too small to see with the naked eye. So geologists make thin sections. This is about 30 microns thick. It's polished, and we can put it onto a petrological microscope like this. That means that we can identify and classify minerals that are down at a small fraction of a millimetre across, and we can understand the textures, look at minerals and when they formed. Did the minerals in this rock form before it was erupted? Well, I can tell you that if I look at the thin section.
Can you tell me how that feeds into the Open University's teaching excellence?
So I got interested in the way that we use microscopes. So when we teach undergraduates about rocks, we teach them how to recognise textures, how to recognise and identify minerals. We teach them about fossils. A lot of that is about learning to see like a geologist. Now, in a conventional university, a lot of students would get a microscope like this on a bench, and on a Wednesday afternoon they'd spend 3 hours looking down the microscope trying to recognise things. The Open University is a distance learning institution, so we can't do that. It would just cost a huge amount of money to send one of these things out to each student. But what we're actually learning doing this is we're learning to recognise different textures. Nowadays, you can do a lot of this sort of stuff online. So I was involved in developing the virtual microscope, which delivers the images of microscope slides through a browser system. It's very much like Google Earth, except for rocks.
So what kind of things would they see then down the virtual microscope, and why is it virtual?
It's virtual because it can do things that a real microscope, a standard microscopes can't do. You can see the different kinds of lighting simultaneously. You can see, instead of looking down a microscope when you're seeing just a tiny part of it, with a virtual microscope, you can actually almost fill the whole screen with this image, and it's gorgeous. I mean, some of the colours are fantastic. And it means that the students can really get the interest and excitement of seeing rock textures. Things like we were describing, like you can, from a virtual microscope thin section, you can determine whether the crystals formed before the lava was erupted. And you can see the different kinds of crystals, the big ones that formed early, the little ones that formed late.
Simon, thank you.
Thank you.